Some airports include a wind shear warning if it's been reported by a pilot on approach or departure, or even if it's been forecast. You'll see this clearly denoted by the letters WS, followed by the specific details of the report. You can grab more information about the report from ATIS, Volmet, or directly from Air Traffic Control. A trend forecast is valid for 2 hours following the observation time and is conveniently attached to the end of the meter. It highlights the expected changes in conditions relative to the actual weather you are seeing right now. Keep in mind, though, that trends aren't routinely produced at every aerodrome that issues a meter. The coding follows the TAF format closely, and we'll dive much deeper into that in our next lesson on decoding the TAF. A key difference with the trend is that we use the code NOSIG to signify that no significant changes are expected over the next 2 hours. When there's snow or other runway contamination, an additional 8-figure runway state group is added to the end of the meter. You might hear this referred to as a SNOTAM, and it's provided by Air Traffic Control. It follows a specific structure, the runway designator, the type of deposit, the extent of contamination, the depth, and finally, the friction or braking action. You'll see an equals sign at the end of the meter to mark the completion of the message. Let's walk through this final example together. The ICAO code identifies this as a meter for Paris Charles de Gaulle on the 8th of the month at 2020 UTC. The wind is from 150 degrees true at a 10-minute mean speed of 16 knots, with a maximum gust of 28 knots recorded in the last 10 minutes. The wind direction varied between 090 and 180 degrees true during that same 10-minute period. Visibility from the observing point was 4,500 meters in a light snow shower. We have few clouds at 500 feet and broken cumulonimbus at 1,100 feet, with an air temperature of +2 degrees Celsius and a dew point of -2 degrees Celsius. The QNH is 989 hectopascals, and we've had thunder reported in the last hour. Wind shear has been reported for runway 12, and the trend for the next 2 hours suggests an improving situation, with visibility increasing to 10 kilometers or more and cloud coverage becoming scattered at 1,300 feet, though cumulonimbus remains present. A useful variation of the meter is the special report. It follows the same format but is identified by the abbreviation SPECI right at the beginning. A SPECI is issued whenever weather conditions undergo a significant change between routine observations, alerting you to either an improvement or a deterioration in the weather. It is worth noting that military METARs can vary slightly from civil coding rules. They often append a color state, a code representing specific cloud and visibility conditions, where blue indicates the best conditions and red the worst. Great, now that we have a solid grasp of how the meter code is constructed, let's look at how to interpret those meanings. When you are scanning through METARs during flight planning, it is a great habit to read the reports not just for your departure, destination, and alternate aerodromes, but also for a station located upwind of your destination. Doing this provides a valuable preview of the weather systems headed your way. But how does the meter code relate to the actual weather being experienced on the ground? In this example, our synoptic chart shows a frontal depression approaching northwestern Europe, with a ridge of high pressure following to the west. Additionally, an area of high pressure is centered over the Mediterranean. To start, let's take a look at the weather in Brussels, Belgium. We can see that Brussels lies to the east of the approaching warm front, so the surface wind will be roughly southerly at around 10 knots. The cloud cover will be thickening and lowering as the front approaches, but at 12Z there is no significant weather and the cloud base remains above 5,000 feet. As a result, the meter reports CAVOC. It is important to remember that CAVOC does not indicate the poorer weather approaching. That information is found in the trend. There are 4 other airports on this chart: Paris, Brest, Shannon, and Madrid. Each of these stations will be highlighted for you, accompanied by 4 different meter options: A, B, C, and D. When each station appears, take a moment to select the meter that you feel best matches the expected weather for that location. Our first station is Paris. Please select A, B, C, or D. Correct. Moving on, our next station is Brest. Please select A, B, C, or D. Spot on. Our next station is Shannon. Please select A, B, C, or D. Excellent. Finally, we have Madrid. Please select A, B, C, or D. That's correct. Just remember that these examples are generalizations. No two synoptic situations are ever identical, and real-world conditions can and do vary greatly. The primary drivers behind these patterns are your geographical location and the local orography. In exposed mountain regions, you'll find that winds tend to be much stronger and gustier, while temperatures are generally lower and hill fog becomes a frequent concern. Likewise, coastal areas are typically windier, and in many spots, you'll need to watch out for sea fog rolling in. During the winter, showers are far more common on windward coasts than inland, and depending on the time of year, you might also encounter distinct sea breezes. Inland areas are usually more sheltered, though keep in mind that this results in higher daytime maximum temperatures and cooler nighttime minimums. Come summer, these inland zones can be prone to showers and intense convective activity, including everything from hail and thunderstorms to even the occasional tornado. You can also see a significant sheltering effect, particularly to the lee of high mountain ranges. Classic examples of this include Aberdeen, situated to the east of the Scottish Highlands, and Denver, sitting to the east of the Rockies. Another crucial way to stay ahead of aviation hazards is by utilizing the local airfield warning system. While the specifics of this system vary from one aerodrome to another, so always check the local rules. It's well worth paying attention to these warnings as they provide vital context about local conditions. We'll dive into this information in much greater detail when we reach the end of our lesson on TAFs. That wraps up our look at METARs, but remember, there are many other excellent resources available to help you build a comprehensive and safe flight briefing.